To make the search for life beyond our planet more systematic and focused, scientists have developed a metric known as the Earth Similarity Index, which measures the similarity of a planet or moon to Earth based on various parameters such as temperature, atmospheric pressure, and habitability. It ranges from 0.0 to 1, with 0.8 and 1 indicating that a planet is similar to Earth in every aspect. In recent years, advances in technology allowed us to uncover a multitude of exoplanets and moons with striking similarities to Earth. One of them was found in 2019 and called Teegarden B. This is a super-Earth, orbiting an M-type star every 4.9 days at a distance of 0.0252 AU. The Teegarden star is one of the closest stars to our solar system, located about 12.4 light-years away from us. And although the red dwarf is 10 times less massive than our Sun and has a temperature of just about 2,700 degrees Celsius, it can still provide enough heat for its 2 planets. The 2 exoplanets are similar to the inner planets in our solar system and are only slightly more massive than Earth. Both of them are situated in the habitable zone where liquid water can exist, but Teegarden B seems much more promising, and here's why. Teegarden B has been given a score of 0.95 ESI, meaning it's the most Earth-like planet discovered so far. There's a 60% probability that the exoplanet has a temperature surface environment with temperatures ranging from 0 degrees to 50 degrees Celsius, and if its atmosphere is comparable to Earth's, the surface temperature would likely be around 28 degrees Celsius. Teegarden C, however, is farther from its star. It has a 0.68 ESI score and only a 3% chance of having a warm surface temperature. If this world's atmosphere is more similar to that of Mars, its estimated temperatures would be around minus 47 degrees Celsius. Researchers are not sure what the atmospheres of the 2 planets are, but Teegarden B and C are tidally locked to their star, and a thin atmosphere could distribute heat and cold across the dark and light dividing line. Scientists estimate that atmospheres with densities between 1/3 to 17 times that of Earth's could allow for liquid water to be present on the surface. But that's not all. There's a planetary system that offers some of the best candidates for extraterrestrial life, and the discovery of its most promising candidate has just been announced. The TOI 700 planetary system is known to have at least 4 planets, 2 of which are in the star's habitable zone. The most promising are TOI 700E and TOI 700D, both being rocky and having similar masses to Earth. TOI 700E has an orbital period of 28 days and is 95% the size of Earth, while TOI 700D has an orbital period of 37 days and is 105% the size of Earth. The TOI 700 system has been around for more than 1.5 billion years, giving more than enough time for biological activity to take hold and transform the thin region where the planet's surface meets its atmosphere into a rich biosphere. If TOI 700E and TOI 700D have an atmosphere, they would be much warmer than Earth's average temperature, a potential game-changer in terms of habitability. Scientists suspect that there could be more planets located beyond TOI 700D, and if one day we were to discover life forms on any of these worlds, we likely hope that they resemble those found here on Earth. But is it theoretically possible that similar life forms could exist on other planets? Evolution is considered a universal law of nature, just like gravity. Because of this, the principles of evolution found on Earth can be applied to other planets due to the process called evolutionary convergence, where unrelated species can evolve similar adaptations to similar environmental challenges. The starting point of life on any alien planet must be simple, and on many of them it could have remained like that. But if some of these worlds developed complex forms of life, it could have only been achieved if beneficial changes were preserved and harmful ones were discarded. An example of this is flight, which evolved several times on Earth through the development of wings. In an environment filled with fluid like water, one can either float if they're lighter than the fluid, or use wings to fly aerodynamically and generate lift. For example, the wings of bats, birds, and insects all serve the same purpose, but they've evolved independently of each other. Similarly, if 2 exoplanets have identical conditions, such as temperature, atmospheric pressure, and access to water, it's possible that life could arise on both planets and evolve in similar ways to adapt to their environments. Additionally, the presence of similar conditions on exoplanets could also lead to the development of similar biochemistry. For example, life on Earth is based on carbon, and it's possible that life on exoplanets could also be based on carbon if the conditions on those planets are like those on Earth. So, if Teegarden B, Teegarden C, or TOI 700e support life, there's a high chance it could be carbon-based and, at least to some degree, resemble life on Earth. But it's possible that life in the universe may take on forms that are vastly different from what we know and understand, and it's important to keep an open mind to the possibility of discovering life that's unlike anything we've ever seen before. Even here on our planet, we have extremophiles, organisms that are able to survive and thrive in extremely harsh conditions that would be lethal to other forms of life. These life forms can serve as examples or models for potential unusual life forms that may exist on other distant planets. So far, the search for alien life has mainly focused on Earth-like planets. But what if we were to shift our perspective and look for something else? A form of life as we don't know it. Perhaps a world with unusual life forms may have a distinct and diverse set of planetary characteristics that set it apart from other more conventional planets. These characteristics may be required for the survival of extremophiles, such as extreme temperatures, high levels of radiation, or high atmospheric pressure. Just a few years ago, astronomers discovered a new class of exoplanet known as the Hycean planet. These planets are very different from Earth, but may be able to support life. The Hycean planets are hot, ocean-covered planets with hydrogen-rich atmospheres, allowing for a larger habitable zone compared to Earth. Scientists believe that the discovery could lead to the possibility of finding signs of life outside our solar system within the next few years. Ocean planets can be up to 2.6 times larger than Earth and have atmospheric pressures reaching nearly 200 degrees Celsius, but the oceanic conditions could support microbial life similar to Earth's oceans. These planets also have different environments, such as dark Hycean worlds with potentially habitable conditions only on their night sides, and cold Hycean worlds receiving little radiation from their stars. The surface pressure on such a planet would be similar to the bottom of the ocean on Earth, where life still exists. This suggests that life could possibly thrive under a heavy atmosphere on a Hycean world. What's interesting, the biomarkers are easier to detect in the atmospheres of such planets due to their large size and higher temperatures, compared to those of rocky exoplanets. Besides, a significant portion of the known exoplanet population, which is nearing about 5,300, consists of planets that meet the criteria to be classified as Hycean. One such mysterious world is called K218b. Discovered in 2015, the planet is among hundreds of those found by NASA's Kepler spacecraft. K218b is located 124 light-years away from us in the constellation Leo. It's a mini Neptune that orbits a dim red dwarf. Researchers believe that in some cases, planets like K218b could support life because they may have such biomarker molecules like methyl chloride and dimethyl sulfide. Life forms on a Hycean planet would likely be based on hydrogen-based biochemistry, as hydrogen is the main component of such a planet's environment. This would mean that organisms there would have a fundamentally different structure from carbon-based life forms. They could be completely unknown to us and have a completely different appearance and structure from anything that we've seen before. There's even a possibility we wouldn't be able to recognize life based on hydrogen biochemistry as living things. Astronomers are eagerly waiting for the opportunity to gather spectroscopic observations of Hycean planets quite soon. They have a number of Hycean-like planets to study, which are located relatively close to us, ranging from 35 to 150 light-years away. And the James Webb Space Telescope already has the capability to examine their atmospheres. It seems like a series of mind-boggling discoveries lies ahead of us. But let's expand our viewpoint even further. How can we determine that Earth is the optimal environment for life? It clearly supports our existence, but we've had ample time to adapt to our surroundings. What if there exists a planet elsewhere in the universe with even more favorable conditions for life? This concept, known as superhabitable worlds, has already been explored within the scientific community. Superhabitable worlds would be older, slightly bigger, slightly warmer, and potentially more humid than Earth. Additionally, they'd orbit around stars that are older than our Sun and have longer lifespans. Our star is expected to last about 10 billion years, and it took around 4 billion years for complex life to develop on Earth. However, some stars can live longer than that, providing more time for life to evolve. So how do we find these worlds? One idea is to look for planets around K-stars, or orange-red dwarfs, which are cooler and less luminous than Sun-like stars, but have lifetimes ranging from 20 to 70 billion years. Compared to Earth, life on a planet orbiting such a star would have more time to evolve and adapt. The ideal age for a planet would be around 5 to 8 billion years old, but no older, as it would eventually lose its interior geothermal heat and protective geomagnetic fields. Another characteristic would be the size of a planet. Being around 10% bigger than Earth, a super-habitable world would provide more land area suitable for life. Make such an exoplanet 1.5 times as massive as Earth, and you'll have a longer-lasting heat source from radioactive decay in its interior and stronger gravity to retain its atmosphere. And since there's more diversity of life in warmer and wetter regions, such as tropical rainforests on Earth, a super-habitable planet would also need to have a mean surface temperature of about 5 degrees Celsius warmer than our home planet. It seems scientists have figured out a recipe for the perfect planet, but is it even possible such a world exists? Researchers have already identified about 24 candidates for such exoplanets. In the near future, one of our telescopes could stumble across a planet that would be well suited for humanity. The search for alien life forms on a perfect new home for mankind continues. We may never know what lies beyond the stars, but it's exciting to think about the possibilities. What kind of world would you choose to call home? Leave a comment and let us know. And don't forget to like the video and subscribe to the channel as we explore the wonders of the universe.